All right, so today, I think I mentioned this yesterday, but today is the most important lecture for the next 4 chapters. Okay, we are covering 10.2, but this is going to help you with the rest of the semester. Okay, and so what we're going to do, what I would like to title this is the outline for hypothesis tests. Okay, and I'm going to give you a list of 8 steps. Okay, so in one sense, you're going to find class is going to be very repetitive because we're going to go through these 8 steps almost every day. Okay, and that's good because I want you to kind of memorize this. This is a long, in fact, my notes today are 5 pages long. I may post this, I think I probably will. I'll probably post this later because it's very useful. Okay. So the other thing that I just want to mention before I write anything on the board, we've already learned some confidence intervals. A lot of the assumptions that we're going to learn relate both to confidence intervals and hypothesis tests. You can think of hypothesis tests and confidence intervals of 2 different methods for accomplishing the same thing. Okay, but I'm going to focus mainly on the hypothesis test, because that's what we're going to be doing in chapter 10. Okay, so the first step is to list all important numbers from problem. Okay, so things to be looking for. Are they proportions or are they means? Okay, you need to be able to distinguish the difference. That's going to be a very important skill. Part B, list the standard deviation, and is it from a population or a sample? You need to distinguish. Okay, I know we learned that clear back in chapter 1. It's going to come back with a vengeance, and depending on which one it is going to affect how you do the problem. C, other things to note. Note your N as well as your alpha. Okay? And if I don't tell you alpha, assume alpha equals 0.05. Because I often forget. I apologize. So just assume 0.05 if I don't tell you. Okay? All right, step number 2 is the data categorical, quantitative, or regression. Okay? We're going to use the answer to that question for the rest of the test, so that's going to be an important skill to figure out. Step number 3. Find the null and the alternative hypothesis. Okay? I'll turn up the light and see if that helps a little bit with the video. Okay? All right. Hopefully, I think most of you did pretty well in today's quiz, so hopefully that's a nice, easy thing. Step number 4 is the hardest step, okay, so far. Okay, and step number 4 says to pick the correct test statistic. Okay, there's only 13 choices that we're going to teach you today. Okay, so we're going to go, I'm going to give you all 13, even though we're not going to cover all 13 today. But, so I will say this. Okay. In past semesters when I taught this, I would say, okay, so how do you decide which test to pick? And somebody gave me the right answer, and I said, how did you do that? And they said, because I memorized your outline. And I was like, wow, that's impressive. I expect you to know these 8 steps. I don't expect you to memorize step 4, but if you do, it'll probably help you get the right answer. Okay? All right, so step 4, okay, based on step number 2, is if the data are quantitative. Okay, if the data are quantitative, I'm going to give you a list of, I think, 7 tests that it could be. Okay, number 1 is, can we see that on there? Yeah, we can. Step number 1 is a 1 sample mean where we know population. Here, I'm going to put it this way. Know the population standard deviation, which is sigma. Okay? In that case, it is a z-test. Okay? Number 2, a 1 sample mean, and you don't know sigma. In that case, it's going to be a t. Okay? Step number 3 is going to be a 2 sample mean, which is independent. Okay? In that case, it's going to be a t distribution. Terrible looking t. Step number 4 is going to be a 2 sample mean, but this time it's going to be dependent. It's also a t, but it's going to be a different equation. I'm not going to give you the equation today. We're getting the log on higher on the board, okay? Step number 5 is what we're going to call the Anova test, okay? Which is more than 2 means. That's going to be an F test. We haven't learned that one yet, but that's what it's going to be, okay? Step number 6. Sorry. Every once in a while I get a call from the Dominican Republic and it's always the wrong number. It's weird. Step number 6. 2 population standard deviations. Okay. That one's also going to be an F test. Okay. Step number 7 is going to be a 1 standard deviation. That one's going to be the chi-square test. Okay. All right, so that's all if you pick quantitative on step number 2. Okay. Now, part B, if the data are categorical. Okay. Only got 5 tests to choose from with categorical. Number 1 is 1 proportion. That's going to be a z-test. Actually, well, I'm going to put a second one here. This is also 1 proportion, but it's going to be a small sample. Okay, that one's going to be binomial. Okay, so we'll assume this is a large enough sample and small enough sample. How do you decide if it's small? NPQ is less than 10. You're going to use a binomial. If it's greater than 10, you can use the z. Okay. Number 3 is going to be a 2 proportion test. That one's also going to be a z. Step number 4 is going to be an independence test. That one's going to be a chi-square test. Step number 5 is going to be what we call the goodness of fit test. That one's also going to be a chi-square test.
What is that? Sorry. The goodness?
Goodness of fit. Okay? And then part C, we're going to talk about regression. Regression is generally a slope test, and that one's going to be a t-distribution as well. Okay? So, those are the 13 tests we're going to teach you over the next whatever weeks. Okay? He's taking a picture, but I'm only halfway done with my homework. Okay? So this is why step number 4 is the hardest step, without a question. Because if you miss this one, you're screwed. Okay, for the rest of the problem. Okay?
Does that say slope?
Slope, yes.
And it's a t-test?
It's a t-test. Okay? So we've learned t, chi-square, and we've learned z. Okay? So we only got one more new one to learn on the f-test. We're not going to learn it today, though. Okay.
And then you said there's another one on underneath quantitative, the 2 sample mean dependent.
Yeah, they're both t.
Oh,
They're different. They're different equations, though. But they're both t-tests. Okay. All right. So now step number 5 is to find the p-value. Okay. And as a hint here, I'm going to say, first of all, what would Rick do? Draw a picture. And part B, this is what I forgot to tell my other class, is you're going to double if it's a two-tailed test. Okay? All right. Step number 6 is compare to your alpha. Okay. And I'm going to give you a little phrase. Oh, actually, no, I'll give that to you in just a second. Step number 7 is decide whether you're going to reject or do not reject the null. Okay? Now I'm going to give you the phrase that pays. It is not a politically correct phrase. Apparently they teach this in the math lab. But it is memorable. Okay? And it will help you hopefully get this. The other irritating thing to me is they get the whole problem right, and then we get to this one and we screwed up. Okay? And that says if the p-value is low, reject the O or the null. Okay? And when we're talking about the p-value is low, we're comparing that to alpha. Okay? Finally, I know we're low on the board again. Step number 8, write the conclusion in English, not statistician. Okay? Which means do not use the words reject or hypothesis. And especially if you want to lose more points than the problem is worth, don't use the word accept.
Support.
So support is okay. Okay? But don't use reject, don't use hypothesis. Before yesterday, you didn't even know what a null hypothesis was, right? Okay? All right. So let's do an example out of the book. Okay? In fact, I'm going to pick a different color, and we're going to go through these 8 steps as we do this. Okay? All right. So, let's say that a researcher in Illinois finds 219 of 500 earn a 22 on the math ACT exam. Does this represent that less than half of students are prepared for college math? Use alpha equal 0.05. Okay? All right, so that even fits on there on this camera, that's good. Well, you guys can't see what I'm doing here. You got to make sure that I'm sharing properly. All right, so let's go through the steps. Step number 1, list all the important numbers from the problem. Are we talking about proportions or means in this problem? What do you think, Mackenzie? Okay, it looks like we're talking about proportions. Do you see any proportions in the problem? 219 out of 500, okay? So something equals 219 out of 500. What is that something? Hmm?
Sorry, what was the question?
You said we're talking about proportions. You said that something equals 219 out of 500. Is it P? Who agrees with me that it's P? 1, 2, is it a 3, 4, 5, 6, 7? Who thinks it's something else? 1, 2, 3, 4, 5. What do you think, Drew?
N?
N? Who thinks it's N? No? Weston, you raise your hand, didn't you? What do you think it is?
P hat?
P hat. Why do you think it's P hat?
It's X over N.
X over N. Isn't P X over N too? It is. So P or P hat? Who thinks it's P hat? 1, 2, 3, 4, 5. Oh, we got a tie now. P or P hat? Drum roll, please. It's P hat. Why is it P hat?
The point estimate?
The point estimate, and it comes from the sample. This 219 out of 500 is my sample, correct? Okay, does that make sense, Mackenzie? All right. Earn a 22, is 22 useful for this problem? No, it's just kind of a descriptor. We're saying 22 means you're ready for college math, okay? Does this represent that less than half of students are prepared? Okay, so let's back up here. So we've got a proportion 219 out of 500. Is there a standard deviation listed? There is not, which means we either don't know it or we need to figure it out ourselves. Okay? Do we know an N? What is the N? The N is 500, and my alpha, 0.05. Okay, it was actually listed this time, I didn't forget. Okay, all right, so we're done with step number 1. We've got everything done. Okay, is the data categorical, quantitative, or regression? Let's vote. Who says it's categorical? Nobody? Who says it's quantitative? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who says it's regression? Nobody? Okay. Y'all got it wrong. It's categorical. Why is it categorical?
Because it's referring to students taking the math ACT.
Okay, what are the categories?
So math ACT.
They're ready for math.
They're ready or they're not ready. Okay. If it was quantitative, we'd be talking about means, but we're talking about proportions, therefore they're ready or they're not ready.
So those correlate with each other. The proportions are always categorical.
Proportions correlate to categories.
Always categorical. Or depends on the question.
So proportions are always categorical. Categorical is not always proportions. Okay, how's that? Perfect. Clear as mud? Okay. All right. Find the null and the alternative hypothesis. The null hypothesis. Let's pick on Stephen. What do you think the null hypothesis is? Now, by the way, before you answer that question, can you go back to yesterday's notes? I think there's actually something I forgot to tell you yesterday. But tell me what I told you yesterday for what does null hypothesis mean? What'd you say? Almost always has an equal sign. I'm going to put an equal sign right there. Okay, what else?
Assume true until otherwise.
Assume true until otherwise. What?
Until otherwise proven.
Okay. It's always about a population. That's a very important one. Wasn't there one more?
Yes, statement of no change, no effect.
Statement of no change, no difference. So it's always about the population. Here's one that I forgot to tell you about the null yesterday. So if you want to add this, it's often not stated in the problem. Okay, that's another useful thing. Okay, so Stephen almost always has an equal. We put an equal in there. Always about the population, it's always about the population, and it's a statement of no change, no difference, or a fair coin, or whatever. Okay, so using that information, help me write the null hypothesis.
The null hypothesis be that the proportion is 219 over 500.
Okay, so you said proportion. I want you to pick a letter.
The P.
Is it P? P, and you picked P because it's a population. Okay, so P equals
219 over 500.
219 over 500. Who agrees with Stephen that that is the correct null hypothesis? 1, 2, 3, 4, 5, 6. Who disagrees? 1, 2, 3, 4, 5, 6, 7. Okay, McKenna, what do you think it is?
It's 19 over 500 referring to the sample.
219 over 500 comes from the sample. That represents P hat. Okay, so what should it be? You were correct, by the way, so it's not. So this something's wrong.
Should be 0.5.
Should be like the half of students prepared.
Half of students. So P equals 0.05 or 0.5? 0.5. Okay, and this is where it comes in. It's often not stated directly in the problem. The alternative hypothesis, you can add this to your alternative hypothesis, is often stated in the problem. Okay? So, in this case, here I'll underline this. Does this represent that less than half of college students are prepared for college math? The alternative, Braden, would be
He is going to be less than 219 over 500. Oh, sorry, 0.5. My bad.
You sure?
Yeah.
Really sure?
Yeah, because it wouldn't change.
Because it's what?
It wouldn't change.
Okay, so this is also 0.5.
Yeah.
He is less than 0.5. Because it's often stated in the problem, and yes, this is stated directly in the problem right here. The alternative is stated. Oh my gosh, we're out of time. We're going to have to hurry a little faster here. Okay, it's not quantitative, it's categorical. Do you all agree that it's a one proportion z-test? Okay. The equation, I didn't realize we were so short on time. P hat minus P over the square root of PQ over N. Okay? This is the equation that we're going to focus on today. Okay? So in this case, Z equals 219 over 500 minus 0.5 over the square root of 0.5 times 0.5 divided by 500. Okay? That's going to give us a value of negative 2.77. Okay? So I've just found my test statistic, negative 2.77. I need to find the p-value. What would Rick do? Rick would draw a picture. 0, negative 2.77. I want the area to the left. I'll double if it's two-tailed, but this is a one-tailed test. Okay. When I look this up on the chart, I'm going to get 0.0028, or I could also use the computer to find that. I'm sorry for rushing through this, but we're way out of time. Compare it to alpha. Alpha is 0.05. Is my p-value less than my alpha? Yes. So therefore, I reject the null. Okay. I don't believe that the null is half the students are prepared. I think that the alternative is true, less than half. So writing the conclusion, there is evidence that less than half of students are prepared for college math. I apologize for rushing through that. Okay? So the homework will be mostly on this equation tomorrow. So yeah, 10.2, but you're going to want to save this for the rest of the semester. We're going to go through this whole thing. Okay? See you all tomorrow. That clock's fast. I still needed to rush, but that's not as